So JavaScript is single-threaded, right? It can only do one thing at a time. But how does it handle heavy asynchronous tasks without freezing your browser? The secret lies in the event loop. When the JavaScript engine encounters heavy asynchronous tasks, it moves them to the browser's web API to be handled. And when they are handled, they are not immediately moved to the call stack for execution. They are moved to two separate queues. Let's take a look at some code. We have a synchronous console.log here that prints start. We have a set timeout that executes this callback function after 2000 millisecond or 2 second. We have a fetch request that logs in some data. We have another set timeout that waits for 3000 milliseconds this time or 3 minutes. Then we have our second fetch request that again fetches some data and logs it. And in the end, we have another synchronous console.log statement that prints end. Now how will JavaScript execute this? The first log is immediately moved to the call stack and executed. Start is printed. Then it encounters the first set timeout. The JavaScript engine knows this will take time, so it's moved to the browser's web API. After this, there is our first fetch request that would also take some time and is moved to the web API. Second timeout moved to the web API. Similarly, the second fetch request moved to the web API as well. Now, our synchronous console.log at the end will be immediately moved to the call stack and executed, printing end. Now, the fetch requests, which are promise-based callbacks, are moved to the Macrotask queue. They take preference every time. The event loop checks if the call stack is empty. If empty, then moves the function from the Microtask queue to the call stack for execution. Asynchronous callbacks are moved to the task queue. The event loop does the same thing with the task queue, but remember, the Microtask queue always takes preference. We can try executing this code in a terminal and see the result for ourselves. We start, end, our first fetch request, our second fetch request, waited for 2 seconds, and waited for 3 seconds. One thing to note here that this is your best case scenario. Our data arrives on my fetch request before 2 or 3 seconds. It can happen that you have a stored network and your data arrives much later, say 10 seconds. Then your timer functions will execute first. But the moment something arrives in the Microtask queue, the event loop will prioritize that.